I'm David Doctor, President and CEO of E4 Carolinas. Welcome to the October 13th version of the Digital Technology webinar series, sponsored by SIA Partners. So, Crystal, why don't we go, or Khalil, why don't we go to the next slide? Thank you. So you can see our program today. You get to listen to me for a few minutes, not 15. By about 1:15, we'll move over to our speakers. And Janine Koch with SIA Partners is going to introduce our speakers in just a minute. We'll then, after about 15 minutes each of presentation, we'll get to about 2:15, moderated panel discussion. With regard to questions that you may wish to pose, if anyone who is in the participating audience, if you have a question, if you would put it in chat, and the WebEx chat function can be found by simply moving your cursor down to the bottom. You may have your toolbar displayed, sometimes it disappears, but just move it down to the bottom or move it up to the top. And over on the right-hand side, you'll see participants, so you can kind of check in and see who's listening right now. You can send them a personal chat by clicking on their name and using the little chat button. Or off to the right of the participant button, you'll find a chat button. Please use that to pose your chat questions. And we get to 2:15. Janine will lead us through moderated discussion, and then as we finish with moderated discussion, we'll move on to audience Q&A, which is your part. Before we get started today, we always take a moment to discuss safety. And the thought I'll share with you today is that we have been in this mode, let's see, it's October 13th. On March 13th, E4 Carolinas made the decision to begin virtual operation in response to the pandemic. That was 17 months ago. So the safety idea I'd have you to keep in mind is that we are all reaching fatigue, or have already reached fatigue with regard to screen time and alternative activity time, travel, etc. So just be mindful that folks that you work with, family members, etc., may have reached a point to where they're not their usual selves, and you can't expect the usual performance out of them. Next, it's my pleasure to introduce Janine Koch. Janine is a head of energy for the U.S. for SIA Partners. She actually joined SIA Partners earlier this year. She has a business degree from Loyola University of Maryland. From there, she joined PricewaterhouseCoopers. She managed audits, was manager of acquisition and transition for financial services. Following 7 years with PwC, she joined CCG Ventures, where she served as the CFO and a partner. Then she served 12 years with Deloitte. You aren't that old, Janine. Do all this, probably started when you're 12, right? She practiced in their Houston office with Risk Advisory Partner, and then more recently was with Accenture before moving over to SIA Partners. So as you can see from her background, she's had lots of energy industry experience. So Janine, if you would next lead us through a introduction of our speakers, tell us a little bit about SIA Partners, our sponsor, and then we'll give Khalil an opportunity to run the Mentimeter.
Thank you for joining, everybody. Thanks, David. It's good to be here. Happy to have SIA Partners sponsor the webinar here. Seems as though I've moved around in the last couple of years, and as David pointed out, 17 years of COVID. I had a couple of kids I needed to take care of. I have 3, one too many, just don't know which one. And so that caused a lot of different things in terms of, are we in the right place at the right time? And I'm sure we've all experienced some of that. A little bit of SIA Partners, I joined because we're more of a niche, very focused organization consulting firm. And I'm actually in Houston, and part of that is growing the office here and the group. We are based in Paris, and you'll hear more from Stephanie, one of our colleagues in Paris, who's missing dinner, I think, at this point. But that's where we're based. We've been in business for about 20 years. 2 of our largest business lines, in fact, are energy and banking. So those two things are somewhat related, I think, particularly now. We focus on, for the energy industry, a lot of AI and RPA and innovation. And one example I'll just give you here to put it in perspective is load forecasting. So we have very sophisticated technology around load forecasting, and that is particularly interesting to me as I suffered through the freeze in February and still experiencing the results there, and anyone else from Houston can probably relate to that. And so we really are experts in the energy industry and are excited to bring these panelists today, talk about very relevant topic. In fact, I'm at a conference right now focusing on those things. So good to have you here and excited for our speakers and their presentations. And as David said, they'll do about 10 to 15 minutes. I'm not responsible for ending their presentations. I'm going to leave that to David just in case they run over. We do have a time schedule. So go to the next slide. I want to introduce our speakers for today. I'll tell you a little bit about Gary, the VP of Market Development and Innovation at Hitachi, ABB Power. So this shows my age because I need to expand this to get a little bit bigger. But so he's Vice President and located in Raleigh, North Carolina, has lots of experience leading T&D equipment sales, business development, etc. Several board of directors and advisory committees for industry organizations, universities, and is a board also here at E4 Carolina, so we're glad to have him. And Mark, as you can see, head of e-mobility at Itron. He is currently the global head of EV payments and partners, and really interested to hear about that. What's going on there should be a topic that's at top forefront of everybody's mind. Lots of leadership roles, product management, strategy and finance, technology development, and everything around that, and earned his degrees from Duke and Miami University. So two different locations, which is both sound fun, actually. And then Stephanie, I'm going to say her last name, Ruadel. And Stephanie can tell me how close I was there. Thanks to modern technology, she recorded her last name and sent it to me, so I practiced a little bit and had Jessica listen in. Not sure if I did it right or not, but welcome to Stephanie. She's with SIA Partners and has been working with companies in the energy sector for about 7 years and is involved in regulatory, which is very important, and innovation. So we'll hear from her. Hey, Stephanie. We'll hear from her. She's lectured and is fluent in French, obviously, and we are happy to partner with our Paris colleagues. They are what I would say give us a perspective from the EU, which is always interesting. I know we're always looking to other countries to see what everyone else is doing and take some guidance there. And then Grant is going to be last, but not least, Business Development Manager for Honeywell. And focuses on providing technical support and training to consulting engineers and users on a wide range of Honeywell smart building solutions. Area of focus is the integration of building automation systems to connected edge devices, such as control valves, actuators, etc. And so I think there's a lot to be learned from that part as well of the business. On that note, we will get started in this order, and Gary, Mark, Stephanie, and Grant are going to pass to each other, so it won't come back to me. They'll introduce the next speaker. And then, as David said, we'll take questions, but all along the way, put your questions in the chat. Don't need to wait to the end. And David and I are tracking those, and we'll bring them back up. So I'll turn it to Gary, and you can kick us off here.
Hey, actually, Stephanie, we're going to move to Khalil for a minute, and he's going to run some Mentimeter questions for us.
Sorry, David, you're right. I forgot.
Okay. Khalil, all yours.
Yes. So thanks everyone for joining today. If you can go to www.menti.com and use the code 4469827 as displayed on the screen, and answer this polling question for us, please. Do you think digital technology can help reduce energy-related CO2 emission? Yes, no, or
Khalil,
more
I think,
interesting?
yeah,
Sorry, go ahead.
I think our group's biased, Khalil.
Yeah, it was interesting to see the pulse of our audience today. It's a good bias, right?
It is a good bias. You're right.
Well, it's a good thing we're talking about this today, I think, based on these responses. So,
yes. Give it about 10 more seconds, and then we'll move on to the first speaker.
Khalil, you got a couple more questions. You want to pose those now?
Sure, I can. Yeah. I'll move on to the next question. The next question is, does sufficient digital technology exist to support an energy-related CO2 reduction to net zero? Move on to the last question.
Khalil, that's an interesting response, and that means that we need to pay attention during our presenters.
Yes. Yeah. No pressure. No pressure. Yeah. All right. Next question. So this is going to be a word cloud, and it's a free text format. So what energy sector will undergo the most dramatic transformation to help reach net zero? It's interesting to see how some of the entries are actually subcategories of other entries. Yeah. Okay.
Khalil, well done. I like this last one.
Thank you. All right, I'll give you another 5 seconds. Okay, well, we'll move on to the first speaker.
So this, I just wanted to introduce Hitachi ABB Power Grids, former Power Grids division of ABB. In July of 2020, Hitachi and ABB formed a joint venture. Hitachi has 80.1% ownership, and ABB has the remaining 19% ownership. Just looking at this slide, it shows our product portfolio. Starting at the bottom, we offer products that include protection and control, such as relaying, transformers, high voltage breakers, capacitor banks, gas insulated gears, substation, high power EV charging infrastructure, high voltage DC, flexible AC transmission system, etc. That was moving up into the middle. But those systems would include the battery energy storage, substation, the HVDC, FACS with the flexible AC transmission solutions, data centers. And at the top, the different software, utility enterprise software for management, performance, field service management, energy optimization, the operational technologies such as data and energy management systems, advanced distribution management, energy market. And then we support the energy industry, infrastructure, and transportation markets. But we're strongest in the utility and energy sector on grid modernization, digital transformation, and energy transition. So just a note, we will transition to Hitachi Energy on November 1st. This is a legal entity name change, but we'll also change all of our. So we have moved to be a direct component of Hitachi Energy based on their majority ownership, and we'll have our name branding consistent starting November 1st. So we're pretty excited about that. So since we're talking about analytics, I just wanted to spend one brief moment in terms of what is AI and the basis of the analytics. I'll talk about these a little bit more presentation slides. So artificial intelligence is really a set of algorithms designed to autonomously handle data analysis. It includes algorithms, but it also can include based algorithms or performance models, also called expert systems. This is symbolic AI. We actually launched our asset performance application using our subject matter experts in symbolic AI to address power transformers and high voltage. Machine learning basically takes historical data, both supervised learning to detect problems as well as unsupervised learning to identify anomalies or data clusters. And on the right side, deep learning based on neural networks has been used in the utility industry for quite some time to forecast grid demand. Now we're seeing expanded applications. These are the topics I wanted to go through quickly. So we'll be mindful of time, and if I start to run out, I may skip some of these, but I will leave them. They will be in the deck, and I'll make it available to anybody who's interested following the session. So first example, asset performance management. Basically, this is looking at different levels of analysis and modeling. Diagnostics level, generally categorize this level as symbolic AI and supervised machine learning to detect anomalies. Utilities are moving to the predictive level. It's more based on supervised machine learning to prognostics, is providing an indication of future events going forward. Then there's still work to be done to move to the prescriptive level as well as the autonomous level. Basically, coming up with recommended actions and autonomous operations, which is really linking outputs and actions to automation with limited user interaction. So we initially launched Asset Health to address power transformers, but we have expanded it to a number of different utility assets, including linear assets such as lines. It did initially include symbolic AI, but now evolved to include both supervised machine learning to recognize a pattern associated with a problem, as well as unsupervised machine learning to detect asset performance or condition anomalies. But this shows that it's a continuous process, monitoring, collecting data, doing the analytics, developing the prognostics, applying the business intelligence, and taking action. You start all over again. So it's a continuous process. So in the theme of tying into carbon reduction and getting to net carbon zero or carbon-free environment, this is an example of asset performance management for wind generation. Basically, it relies heavily on anomaly detection through unsupervised machine learning, but also there's an application of supervised machine learning, which really provides the basis for the prognostic and also moving to the recommended maintenance actions for availability and performance of wind generation. So a lot of detail in this particular slide, but we have applied basically the asset performance management to the wind generation sector, as well as we can do similar types of modeling and analysis on the components of solar PV and also other equipment. Another extension of asset performance management, this is part, I guess, input of data into asset performance management. This is image-based inspection, rapidly growing, particularly with images captured by drones as well as traditional helicopters using inspection on transmission lines. Capturing the data is great, but many utilities struggle to analyze and process image data which can drive value. So the machine learning process requires a historical database, but we need sufficient volume of the images with known problems or defects to train the algorithm or the algorithm to learn. But once we do that, though, the results rapidly improve, and a tremendous amount of time is saved for trying to analyze the images. Collecting the data is one thing, but analyzing the image and detecting problems is a significant challenge for utilities. We're also looking at images, in this particular case, satellite images. Tree trimming and vegetation management are critical utility operations. Cost of tree trimming and vegetation management is a major O&M expense for utilities. Inadequate tree trimming is one of the major causes of storm outage, particularly at the distribution level. So the analysis of the satellite image protection of the vegetation species, and then also can support vegetation risk analysis based on falling trees, wind, ice events, that other intrusion into the right-of-way for the electrical infrastructure. And this is actually a fairly new application, but addresses what has been a classic problem for utilities to optimize their vegetation management and minimize the risk from outages caused by storms. This is another example of machine learning. Basically, this involves training the machine learning algorithm to recognize and predict storm damage and restoration needs. It uses historical data from weather, historical outage management data, asset data, vegetation data. Basically applies analytics to correlate forecasted weather to expected grid impacts based on previous knowledge and stored information in databases that I just mentioned. Processes to predict the impact of the forecasted storm, assess the necessary resources from supply chain management and crews. Once the storm hits, assess the impact of the storm, plan for the restoration, commit the resources, of course, maintain communications with stakeholders. Another example of forecasting using AI, this is for demand and generation. As I mentioned, neural networks have been used for load forecasting for years, but now the aggregated load at the distribution level, which includes traditional customer loads, but as well the impact of renewable distributed energy resources such as solar PV and new loads from electrification. It's increasing the layers of the neural network, making the deep learning application a little bit more complex and sophisticated. Similarly, forecasting available generation resources, which now includes weather-dependent resources like wind and solar, also requires more complex forecasting models. Addressing the weather dependency is not new, since weather significantly impacts load forecasting, but now we're applying that also to generation. So we need high weather accuracy in terms of forecasting, combined with highly accurate load, wind, and solar forecasting to really optimize resource optimization, which does impact utility profits. I want to just touch on digital twins real quick. Digital twins enable comparisons between what is expected based on simulated performance versus actual monitored or measured. On the left side of this chart, we see the transition from the bottom, monitoring and visualization, to full enterprise or to a digital twin. The right side of the slide, we move up from system recommendations to decision support to automated and autonomous operations. Some of the examples of digital twins that we're implementing today. One is a digital twin of the distribution grid. This really relies on an advanced distribution management system, which is coupled to communications and distribution automation or smart devices, distribution circuits to create a digital twin distribution system. The key element of this is the operated network model. This network model can also be used to simulate or for simulation studies to analyze expected grid performance. And why is this important? Today, when we start to look at more renewable distributed resources, we need to be able to validate and optimize expected distributed energy resource dispatch schedules, making sure that we can maintain power quality, the voltage, the operational security of the distribution grid when these resources are dispatched. Perhaps by an aggregator or an IPP who is managing portfolio of distributed energy resources. But the grid operator needs to be able to model that, simulate how the grid is going to perform, determine if there are going to be any operational issues, which basically is embedded in FERC 2222. And then here is the distributed energy resources, which are relying on that network model for simulation, which can be used on sort of the optimization of the grid and the distributed energy resources. I did pull this slide from another person, so I would change the numbering. First number should be on the left, hosting and aggregation by an aggregator of distributed energy resources. Could be the utility, could be a third party. Second part should be really the DER and grid optimization to make sure the dispatch schedules can actually be dispatched, which should be third, which is shown at the top. And then the last item is the market settlement transactions. So I'd move around this diagram a little bit different. We also have digital twins for power equipment. On the left is a battery energy storage system, which would be in the megawatt range, fairly large system. And we're using machine learning and data analytics basically to monitor and determine performance of the power converter and the battery itself. Real-time monitoring, historical data analysis, performance analytics, and of course the operator gets alarms and handling based on any deficiencies in overall performance. The right side, we're doing the same thing for an HVDC, high voltage DC transmission converter stations. We can represent the entire station in 3D. And then we're using virtual simulations for maintenance, troubleshooting, and training. And we have an active, real-time, interactive digital twin with asset data and dashboards. So we also have virtual controls for testing, simulation, verification, performance, validation. Not only the grid itself in terms of the distribution system as we showed previously, but also the equipment in the system. And on the Hitachi side of our company, we're also doing some work on the next generation of grid analysis. This includes learning-based volt-var optimization to manage feeder voltage and minimize loss. Open source software to model secondary loads using a Monte Carlo simulation to determine and also electrification opportunities. Machine learning-based forecast framework, solar DER. This is for, based on, I would say, supervised machine learning based on past history and being able to forecast expected output of solar PV. The last item is an example of deep learning to estimate feeder. So I also wanted to include an example of data science. That's also part of the analytics and really how we address managing. I talked about image-based inspection, talked about asset performance, didn't talk about automated analysis of substation video monitoring application. We apply analytics to monitor substation videos. And the last item on the far right addressed data configuration. One of the challenges, particularly with asset management, how do we streamline the data configuration? How do we match, for example, a high voltage breaker? An unknown model breaker does have a known model, assign the new configuration file to that unmatched asset. A major effort for utilities in terms of managing their configuration files, categorizing data, which then enables them to apply the analytics and be able to study and make inferences on performance and condition of assets. So big challenge for utilities. And I wanted to show the data intensity. So this slide ties back to my earlier slide on data to AI, establishing a vertically integrated. It shows as we move periodic static data left, the near real-time data on the right, we exponentially increase the data applications. This is a bit of an eye chart. Each one of the applications identified in the gray rectangle incorporates data analytics. We have four main areas: visibility and condition, monitoring and assessment, increasing the life cycle value of assets. That's related to performance management, but also system-wide analytics, the OT/IT convergence, and also convergent planning and operations, shift towards risk management, particular risk-based maintenance, then moving indication of failure to integrate things in the system. Moving to that far right to the upper level, where we're implementing autonomous execution of recommendations. This is my last slide. So just key points. Utility analytics are a cornerstone of utility digitalization. Utilities are investing in enterprise IT to leverage the available data, and focusing on the roadmap for analytics use case and operations improvement, which includes being able to accommodate higher levels of renewable carbon-free generation. Last slide. And I'll turn it over to Mark.
All right, thanks, Gary. That's great. Tough act to follow. Let me see if I can share here. How are we looking? Good?
Perfect.
All right. That's the first technology test. Okay. So I'm going to talk a little bit about Itron, just to set a little bit of context, our approach to digitalization and reduction of carbon footprint, reduction of carbon emissions. I'll talk a little bit about a product we're developing. It's really focused on fleet electrification, and I actually have a second focus. We'll see how my time's going in terms of time management, but I think there's a real need in terms of marrying data gathering from a carbon perspective with real-time carbon intensity signals. That is a real need in the market. So I'll address that as well. So in terms of Itron, I think most folks know Itron as more of a metering and network company, and so we do obviously have expertise in that with about roughly 80 million now endpoints under management within our network. I actually sit within what we call our outcomes business unit, which is the software and services that we build on top of the network. And so it's roughly a $250 million division, so fairly substantial, but maybe an area where Itron isn't as well known. But that's where we're really building out our digitalization strategy and technologies, and a lot of it is around resource management. It can be both from a grid perspective as well as more of an end customer perspective that's working with a utility. So our main channels to market are utilities and cities, but obviously the expanse of our solutions go well beyond that. And the only other thing I'll say is, again, if you think about kind of Itron's core AMI, right, advanced metering infrastructure, AMI 1.0 was really all about, it started the process towards gathering data, managing a holistic network, but it left a lot to be desired in terms of really utilizing that data. And one of the reasons was, frequency of data coming back. And so typical backhauls were roughly 15-minute information, 15-minute data sets, backhauled potentially 4 times a day, sometimes a day later. And so where the market's headed now is really all about real time. And I think that's the way we get to true analytics, control, and orchestration solutions that meet the carbon reduction goals we have set out there. So we are deploying technologies that are real time. We have ways to do that with our legacy AMI 1.0 deployments. Increasingly, we've been rolling out a distributed intelligence technology that can that can not only pull real-time data, but has compute capabilities at the grid edge. So we can actually run applications on the meter, and/or again pull real-time data back to the cloud, and then run applications in the cloud. And so I think that has really far-reaching technology implications for a number of applications. So the one I'll focus on is EV charging. And so I come from my last role was at a EV charging company, so this is near and dear to my heart. And if you think about the way the market's evolved today around charging, it's really been around residential, public, semi-public. And so if you think about the EVSEs out there in the market, they've been very focused on expanding their networks, increasing the relationship with the driver, those type of things. But if you think about where the market needs to go, and in order to reach kind of the transportation electrification goals that have been set out there, statewide, nationwide, it's really all about expanding quickly and getting projects done. And so I think in order for that to happen and for us to reach our transportation electrification goals, I think the utility is going to have to take a more proactive role in, one, just understanding the risks associated with the proliferation of EV charging assets, but two, just really working with the end customers. And so one is working with the end customers on education in an advisory role. And I think that's a great way for utilities to really think about how they can extend that relationship with the end customer. And two is really about, again, managing risk. And so our hypothesis is that the grid is going to have to work in harmony, in conjunction with EV charging assets. And it's not just EV charging assets, it's really distributed energy resources. So that's more of a broad-based trend. And again, for the purpose of this conversation, I'll focus on fleets. And so fleets, I think, are a very interesting target in EV charging. Again, it's a newer segment. The fleet vehicles are really just coming to market. And by fleets, I mean it can be light duty vehicles, that can be kind of a corporate fleet. It can be medium duty vehicles, which can be kind of a last mile delivery, maybe a UPS, FedEx, could be Amazon, and then heavy duty certainly is the longer haul, which could be kind of your semi tractor trailers, your drayage type of operations. And so fleets span all of those. I think if you're a futurist and you really believe in autonomous vehicles as well, which are starting to actually get approvals, and especially here in California, actually start to accelerate their business models. Everything could turn into a fleet long term. So you could make a case that vehicle ownership, especially for consumers, will decline over time as ride hailing, car sharing, things like that become better, more economical options. In which case, fleets kind of take over all areas of transportation. And so I do think fleets in general are interesting from a managed charging perspective as well, because if you plan appropriately, if you plan charging appropriately, there's going to be really high utilization on these charging assets. And then the charging patterns are pretty distinct and consistent. What that lends itself to is a managed charging type of application. And so that's where I think the blurring of grid needs and end customer needs comes into play. And that's where Itron's solution is focused. And so again, if you think about managed charging, what you need is a lot of load. And so and then you also need the ability to manipulate that load. And I think, again, if you think about a school bus application where a bunch of school buses are coming back to a depot and all plugging in at the same time, that can be a big load. So that can cause problems for two things. It causes problems for the grid in terms of causing a big demand all at one time. And if there's another occurrence like a hot day and there's potentially other loads on that transformer or feeder or substation, such as HVAC, they're going to cause issues that can cause a massive grid failure. And then on the end customer side, there's no reason for all those vehicles to charge at once either. So that could cause big demand charges, cannot be optimized from a time of use rate. So their utility bill can be out of whack. So there's the ability to spread out that charging in such a case that it manages what the end customer needs, which is those school buses to be charged when they need to be in the morning, and then also manage their utility bill, which is their fuel cost. And then there can also be managed charging for the purpose of the grid, so that there isn't any fatal catastrophic issues with grid infrastructure. So that's a really simple use case to think about what we're doing, but the end game is those two constraints being managed and working in harmony. So we do break this down into different modules. So project planning is certainly going to be key, especially from fleets. So right now we're basically at the pilot stage with a lot of these fleets. So they're wanting to think about, all right, how do I dip my toe in the water, potentially electrify 10 vehicles? And if that works, they'll go to 50, perhaps for the larger fleets, 100, 1,000. And so, initially with that, for that initial fleet electrification, there needs to be an education of the end customer. They need to think about what type of charging infrastructure do I need, and what type of charging schedule do I need based on my mileage needs, based on my battery size of my vehicles, and then secondarily, then you think about, all right, how do I potentially need to upgrade my grid infrastructure? If I need a transformer upgrade, what's that going to cost me? And how does that total cost of ownership work for me as an end customer? On the grid side, they need to be thinking about a similar, a similar analytical analysis. Where they're thinking about, all right, if this customer is going to electrify 10 vehicles, perhaps there's a grid upgrade needed now. But what about if they go to 50, 100? What does that look like? And then what about if, if there's fleet electrification down the street? How does that impact my grid infrastructure? And so that needs an intelligent plan now, and a lot of that can be managed through, digital methods. And so that can be digital twins. Obviously, is a piece of that, which I'll get to in a second, kind of the technology pillars of this solution, but strong forecasting, which can be accelerated through ML catalogs, things of that nature. So project planning is key to this whole thing. Once the project is operational, there's charging management, and so a big part of that is the ability to forecast. And so forecasting for both the end customer, what their charging needs are going to be, not only 24 hours, 48, but kind of weekly forecasts, and marrying that with grid forecasts as well in terms of energy, power, can be voltage, frequency, those type of variables. And again, with charging, we think of electric vehicle chargers as just one of many DERs, and so certainly with fleets, a lot of these depots are going to have not only EV chargers, they're going to have solar storage, and increasingly not only in EV applications, but well beyond that, the lines are blurring between grid and the behind the meter type of assets that are feeding back into the grid, and so that whole equation needs to be managed for multiple stakeholders. And the last one is really transformer management. I'd actually extend that to kind of low voltage grid management, and so certainly secondary transformer management is going to be a key component of this, and in terms of planning out that grid infrastructure upgrade over time, how that meets the needs of fleets and the utility. But that can be extended to primary transformers, feeders, substations, and so that's really all about kind of low voltage grid management. And then in terms of how we think about the tech principles of this, this is going to have to be an open application, really standards-based platform. And really, and the reason for that is if you think about depot type of projects, there's a variety of DERs typically involved, as well as data coming from grid assets. And so being able to use a variety of protocols, as well as assemble cloud-to-cloud type of integrations in order to get that real-time data is going to be key. Hardware and network agnostic, certainly Itron has its own hardware and network, but I think being able to get data from multiple sources, regardless of the hardware manufacturer or network operator, is certainly key to this solution working. We talked about the real-time capabilities of this, and so real-time can be seconds, it can be sub-seconds if you're thinking about more voltage or frequency type of applications. But again, managing constraints for end customers as well as grid needs to be real-time. Born in the cloud, but with local resiliency. So cloud for compute capabilities, local resiliency, specifically when you're talking about fleets. Again, their main goal is to ensure their vehicles aren't going to get stranded at some stage. So if there's some disconnect from a network perspective, there needs to be the local resiliency to keep up that SLA in terms of ensuring their vehicles are charged. So I think there needs to be software both running in the cloud and on local devices. API integrations, we talked about that a little bit. Digital twin based, again, Gary hit on that a little bit. So digital representations of physical infrastructure processes. And so really that's all about a utility or a city being able to visualize, also really see the analytics, and then develop applications, control orchestration applications based off of that. It's going to be key. Really being able to see the data sets in real time, whether that's power flows, can be voltage, frequency, metrics, things of that nature. Multivariant control and orchestration. Again, you're managing. It's multivariant both from an end customer perspective, managing algorithms for them such that their charging schedule works for the end customer, as well as marrying that with grid needs. And so being able to manage that complex equation is certainly takes some sophisticated algorithms. I think design to scale is certainly key. I think this is a millions of endpoints issue over time. And so if you think about EV-SE networks, those are 100,000 at most at this juncture. But once we get into real vehicle electrification, we're talking about managing millions and millions of chargers, millions and millions of DERs, not to mention grid infrastructure. So design to scale is going to be key to this. AI, ML for additional insights and continuous improvement. I think I don't reiterate kind of what Gary said, but this is certainly core to it, both from fine-tuning the algorithms as well as fine-tuning and improving on forecast is going to be key to this. And then microservices, so loosely coupled applications that can serve many needs coming from a platform. And so these are our core tech principles we're thinking about as we're building this out. I think I'm about at time. I'm happy to pass it on. Again, I have another use case around carbon. If we have time, I'll kind of leave it to you guys to tell me whether I should pass it on or hit on this as well.
All right, go ahead with the use case. We're good.
Okay. So smoothly transitioning from fleet electrification to overall carbon reduction. Certainly, fleet's part of the carbon reduction picture and portfolio we need to meet. But overall, what we're seeing is as corporations, both utilities and corporations, are thinking about net zero goals, there's a big gap in the market in terms of how things are being quantified in terms of scope 1, 2, 3, 4 emissions, but also tying that to real-time carbon intensity signals. So truly understanding what a company's carbon footprint is in real time. And so at this juncture, the majority of quantification of carbon emissions is done top down. And I'd say the same for rec matching. So a lot of corporations, when they think about reducing their carbon intensity, they purchase RECs. But those RECs could be purchased based on generation at any time of the day, could be 6 p.m. at night, a REX generated, but the carbon intensity of the consumption of that user could be in the morning, and so there's no matching of true carbon reduction if you're talking about REX. And I think that's a real gap in the market at this juncture. So if I look at the diagram on the right, it's all about informing consumption patterns. And so this diagram basically, or this graph basically, shows a baseline load of an end customer being disparate throughout the day. But if you marry that with a true carbon intensity signal of generation, there can be behavioral changes or even automated control and orchestration such that carbon, that carbon intensive consumption looks different. And so I think one thing we're thinking hard about is developing solutions around gathering the data, hopefully in real time, about and doing that in an efficient manner. So if you think about any large corporation, so let's take a Target, right? There yesterday. So take a Target, they have retail stores all across the country, across many utilities. They have corporate facilities all across the country, around, across many utilities. And so gathering that data first and foremost is really time intensive, and it's not done very efficiently at this juncture. So there's certain companies that have forward-leaning that have been really good at it, Microsoft, Google, perhaps even Target. I don't know for sure, but we've been increasingly talking to corporations that are really having a lot of difficulties in truly quantifying their scope 1, 2, 3 emissions. And so I think that's one problem we can solve through through our network and our devices we have deployed. And I think taking a step further, once you have that data, marrying that with carbon intensity signals that are coming from the generator side or the ISOs, to truly give a real-time carbon footprint analysis, I think is going to be key to really solving these problems. And so I think for this to really gain traction, we're going to need a couple things. One is we're going to need to prove out that this either improves the efficiency of how we get to net zero, and or provides a more cost-effective manner to get to net zero for these corporations. And I think at that point you start to get these corporations' attention, and you have a real product. So I just want to point out that this is something we're working towards, and I think Itron can play a major role in this area as well. Okay, I think I'll pass it on now. Appreciate the time.
Okay, thank you, Mark. I think I'm the next one. So hi, everyone. I'm very happy to be here tonight. So I'll share my screen. Right, can you see it?
Looks great, Stephanie.
Nice. So as Janine introduced me very well before with my name, I'm Stephanie Riodel. So I'm currently a senior manager at SIA Partners in France, and I've been working for several years in the energy sector, and in particular on how digital data and artificial intelligence are transforming our clients' businesses. And today I'm going to talk about a particular aspect, which is the use of data analysis and artificial intelligence.
So sorry.
To reduce.
I was rambling on.
Okay. So first of all, I wanted to make a very quick introduction about the context in Europe and why this topic is a growing interest for our clients. So, as some of you may know, Europe ratified the 2015 Paris Agreement, which sets a target to contain the rise in temperature significantly below 2 Celsius degrees compared to pre-industrial levels by the end of the century. So this is a non-binding target, but there are numerous incentives for companies to commit to reducing emissions. So, for instance, the governments are reinforcing regulations concerning greenhouse gases emissions. Companies have also to take into account their credibility and attractiveness regarding our customers' expectations and also our employees and stakeholders' opinions. And it's also a very good opportunity to create new services, to reduce costs by being more efficient, and also to limit the risk exposure to climate change. And so that's why in Europe, you had a lot of new legislative measures that have been taken to make the companies reduce their greenhouse gas emission. So, for example, the Fit for 55, which is a regulation that aims to reduce the greenhouse gases emissions by 55% by 2030. And we also had really recently the Green Deal, which objective is to make Europe the first climate neutral continent by 2050. So as you see, a lot of companies already announced some very ambitious plan to reach carbon neutrality on Scope 1, Scope 2, and other also Scope 3. And as you see, first the banks and the service providers were the ones that commit. But by 2050, you will also have like energy companies and very electro-intensive companies that are also trying to reduce their carbon footprints. So the problem is how can they reduce their carbon footprint? And we have different levels if you want to meet these objectives. When you look at them, you have a lot concerning energy use. So you can act upstream of the energy value chain, which means decarbonize the production. So to do so, you can use less carbon intensive fuels, which mean, for example, a switch from gas, from oil or gas, or to develop carbon-free energies. So that's all the renewable energies that are concerned here. And in Europe, we set a target of a 40% share of renewable energy in final consumption by 2030. And you can also act downstream of energy value chain, which means reducing the consumptions. And to do so, you can adopt more sober consumption methods, like switching to less consuming equipment, or be more efficient on recovering waste energy. And you can also improve energy efficiency, so for industrial process, for example. And also in Europe, we have an objective on this. We want to reduce primary energy consumption by 39% by 2030. And you can also reduce the non-energetic emissions. which are, for example, agriculture emissions, or you can control the methane leaks. And you can also try to reduce already emitting the greenhouse gases, for example, using carbon sinks, which means planting trees, for example, or you can also capture and store carbon. And what you see here, or what we see when we identify the AI usage in our clients, is that the maturity for AI data analytic use is more on the energy use than the reducing already emitted emissions or the non-energetic emissions. So I wanted to speak a little about how AI and data analytics can help reducing greenhouse gases emissions. I choose to list some use cases we worked on for our European clients. You will recognize some of them. Mark, for example, talked a lot about electrical vehicle. What is nice about AI is that you can use it to monitor and supervise your process, business, and your product usage. So because AI is able to automatically analyze and collect a lot of data, you are able to do stuff a human being can do. For example, you can analyze your consumers' behavior. So I've worked for a supplier, energy supplier in France, and they analyzed the data of energy consumptions from their clients, and they try to identify how they can reduce their consumptions and better consume energy. For example, you can also track emissions from industrial process to see where you can be more efficient and maybe cut some costs, and so emit less carbon. And for example, you can also detect fires and floods. You can do so with satellite images. We've already done a lot of satellite images analyze, and with all this analyze, you can act very quickly and respond to, like for example, fires threats. Another thing you can do with AI is prediction. So, for example, you can predict what will be the future emissions for your company, your business, and as a result, you can adjust and set objectives and track if you're achieving the reduction targets you set. And just to take some example of what you can do, you can carry out production and demand forecasts. So, for example, we did it for wind farms, and the objective was to predict when the wind farms were going to produce more electricity. And if you are able to combine that with a demand for electricity, you can optimize maybe and make the demand fit best way possible to renewable production. The objective is to really consume electricity when it's produced. For example, another one, you can analyze the investment impacts on carbon reduction. So today, if you have a lot of different options for investments, you can use all these data to choose the best way to invest money to reduce your carbon footprint. And the last big thing you can do with AI is to act. So you can optimize, you can reduce your carbon footprint. And we've done a lot of different use cases for our clients on this matter. So, for example, you can optimize your routes or fleet management. We did that for waste management company who wanted to optimize the trucks routes. And with that, they wanted to really save fuel, and so it will lead to carbon emission reductions. You can also optimize renewable energies location and integrations. And we developed a lot of algorithms to help our clients, who could be like TSOs, suppliers, to identify the best location to integrate like solar panels, wind farms, for example. So these are a lot of examples of what you can do with AI and data analytics to reduce greenhouse gases emission. And to make it a little more concrete, I wanted to describe 2 use cases of what we did for our clients, and to help you understand how it works. So first, very quickly, I won't describe more than Janine what is SIA Partners, but concerning AI, how do we work? What we do is that we combine our business expertise and our data science capabilities to create solutions especially designed for our clients. So we call that approach augmented consulting. So first, for the data science part, we developed a platform, ECA, and this platform is really designed to increase the efficiency of the data team. So we have data scientists who can help the companies to develop the algorithm. And internally, we have already developed a lot of bricks to accelerate the projects for our clients. And we also combine that data science knowledge with our business expertise. So when addressing the energy sector, we rely a lot on our energy team, and especially the Climate Analysis Center. And it is a study center that allows us to put expertise to work for a CSR impact for our clients. And in this center, we study the market, we try to anticipate new trends, and we create new offers to help our clients transforming and adapting to the transformation with the climate change. So I choose 2 use cases. The first one is about carbon analysis, which is the first step to set a low carbon strategy. So Mark said it before, you have to be able to track and to assess your carbon footprint if you want to act. And that's what a lot of our clients who wants to control their costs, to prepare for a stricter regulation, and to also improve their image, employees' commitment, and other stuff. They needed a tool to assess their carbon footprint. And we created one that is able to first set up and create a carbon footprint model. So we collect all the data we need, and we make a comprehensive database with all the data we need to do an analysis. And then we exploit this data to really help the client define a strategy to compensate or reduce carbon emission. And the last but not the least step is to really act. So you can take actions to offset the carbon emissions you identified. And for this, I wanted to share with you client assignments with this on this subject. So our clients wanted to improve its greenhouse gas emissions monitoring and be able to communicate on them and have a tool that help decision making. And the objective was to create a dashboard that would be accessible for more than 1,000 employees to help them really reduce their emissions on their everyday activities. And so what we do on this specific project, so we made an approach specific for them that enables us to build a solution fitting perfectly with our client needs. So we supported them with the whole process from the identification of their needs and requirements, the definition of the accounting methodologies, and the setup of the technical architecture, and at the end, the construction of an automated GHG accounting dashboard. So basically how it works, we did it 4 main steps. The first one is the diagnosis and scoping. So here you identify what are the data source you need for this project, what definition you will take for the accounting methodology. So for example, how you can convert your financial data into carbon emissions. And also you define the tool, architecture, technology you want for the project. Then you have to do a data collection phase, and you have to go in all the applications of the client to automatically collect on a daily basis all the data. This is very important because it's what you have to do to have a real-time information in the future. When you have the data, you are able to make some calculations. So you, with the technical and financial data you have, you use the carbon intensity per expense revenue selected before, and with that you're able to calculate a carbon footprint for all the activities of your client. And then because the objective was to be able to communicate about this information and to act after that, you put the result on a decisional dashboard. And this dashboard is some screens with different KPIs the operational manager can use to really control their activities and what improvements they've made since, for example, the previous year or the previous months. And one thing that was very important in this project is that we did it in 2 phases. We first did a proof of concept to really assess the added value of this dashboard, were the KPI useful, and will the teams use it. And then we went to a minimum value proposition dashboard with additional indicators and a larger scope covered. So just like to explain a little bit what we did for the calculation of emissions. For example, for the technical and physical measures, you took everything you're using in your process or activities, for example, electricity, fuel, treatment products, and you take the emission factors. So these factors can be found, they are published by public authorities in France. So you have the list of them. Maybe you can adjust them a little bit for enterprise. And with that, you have the result, and you can see the carbon emissions. And just to finish this use case and stop after that, at the end, what the teams have, they have like a lot of dashboards with all the information inside, and they can, as I said, visualize if some activities were emitting less or more than the previous years. And they can also make like a comparison with other teams. For example, if you have one team in Paris and one team in Lyon, another city in France, they can see if one of them is more efficient, and maybe they can exchange like best practices to improve their process. So that's all for me. I will leave the floor to Grant.
Okay, we'll go through the intro stuff that's been done. The agenda that I'm proposing here for my couple minutes of speaking to you, it's going to be taking a lot of the concepts that I think Stephanie just built on, and it's going to be applying some of these same concepts to your individual commercial real estate asset. And how to apply some of the data collection and analytics technologies to drive decarbonization strategies through your building management system on site. So that was our introduction. I'm going to talk a little bit about the policy environment that we're looking at in 2021 in the US that's driving some of these requirements and some of the actions that building owners need to take. I'm going to talk a little bit about emerging trends as it pertains to the Internet of Things and software as a service style solutions that can be driven through the BMS. I want to talk a little bit about converged architectures and some network considerations related to BMS, and then hopefully bring it all home, making the case that we can absolutely drive sustainability outcomes through your building management system. All right. Real quick, just Honeywell slide. I'm not going to dig into this, but I will state that that nice shiny new building right in the center of the slide there is our brand new global corporate headquarters. It's right across from the football stadium in Charlotte. We are very happy to be there. We moved there about, I don't know, a year or two ago from northern New Jersey, which is where I presently sit. And just the old corporate was a couple minutes from my house. The new one is right down there, and it looks like it's a great facility. And just a quick look at our dealer network for open source building automation solutions. You'll hear me talking Tritium Niagara as we go along here today. This is a Honeywell network of Tritium Niagara installers, so we can meet you in any market that you might be playing at across the country. Okay, so let's get into this policy conversation a little bit. 80 by 50 and decarbonization. So 80 by 50 is something that we have just been hearing a ton about in the Northeast over the past several years here. So what does it mean? It's a policy framework that is aiming at a reduction in localized CO2 emissions of 80% by the year 2050. Now, to get that 80%, we're looking back at a baseline of 2005. So in simple speak here, how much CO2 were we emitting in 2005? We need to be 80% below that by 2050. That is a big challenge. It's cross industries. So, this is buildings, this is transportation, this is waste management, this is power generation. This is all of the different activities in any given society. You roll up their total emissions. Now, the reason that I'm kind of thinking about this in the lens of the built environment and building automation is because globally, buildings account for about 40% of total carbon emissions. And in the United States, about 76% of the electricity that we consume as a country are being consumed by our buildings. So that's a very logical place that we want to put some focus as we're thinking about these 80 by 50 decarbonization laws. Cities that have specific laws on the books already right now: New York, Boston, Philadelphia, DC, the state of California, the state of New Jersey, the state of Virginia, all have 80 by 50 laws on the books. North Carolina took an interesting approach. They kind of went halfway with both. I think they were probably feeling out how this whole policy might work. They did a 40% by 2025 plan, same type of thing, but instead of going for an 80% reduction, you're going for 40% by 2025. So that was a law that's been on the books for a few years. On the flip side of that, Washington State is going towards 95% carbon emission reductions by 2050. Noting there the example of Charleston too, they kind of went in between. Big point here is that this is a movement that has gained a lot of steam in our country, and we're going to be seeing more of it over the coming years. And we're also going to be seeing various industries needing to react to these policies as they're put in place. Another major thing we're seeing are kind of localized efforts towards driving net zero. That could be at the state level, the municipal level, or in the example of North Carolina and UNC Chapel Hill, they have put in their own university-wide net zero initiative. So at UNC Chapel Hill, the goal is a net zero position by the year 2040. So when I say net zero, any kind of localized consumption and localized emissions need to be fully offset by the incorporation of renewables. So if we're kind of looking at it from a balance sheet perspective, we want to be equaling out at the end of the day with renewables offsetting any of our localized consumption. So we're seeing more net zero initiatives popping up. We're seeing energy codes. So the International Code Council is kind of constantly ratcheting and tightening up what energy codes are kind of at an international level. And then we're also seeing local jurisdictions are tightening them even further. So to build new today, you have to be exceptionally energy efficient. And we're going to see that coming more and more into the future. And the last thing I want to mention is we're also seeing a carrot and a stick approach here. So what I mean by that, I can speak kind of to the New York City or New York State market, where the local utility and energy and sustainability programs are putting carrots in front of the commercial real estate community by offering just excellent incentives and rebates for executing building automation related strategies to drive down emissions. So the idea is we're pulling data up into a cloud, we're layering analytics on it, we're identifying through the data sets energy conservation measures that we can then push down to the building and kind of drive capital towards the retrofits that would be required to save energy. And the state is heavily incentivizing that, almost 50% incentives. So that's a nice carrot. But what we're going to be seeing 5 or 10 years from now is if you are in non-compliance with your carbon caps that the laws have basically stood up here, you're going to be getting fined, and it's going to be a very substantial fine. I'm hearing large commercial facilities could be getting hit with up to 7-figure fines by the year 2030 on an annual basis for non-compliance with these decarbonization laws. So this is real, this is here, it's something that's today, and it's something that people really do need to be planning for, because I don't think it's going to be going away. So what are the steps to decarbonizing the built environment? Step number one, we need to be operating all of our buildings, all of our assets as efficiently as we possibly can. There is, in the face of that type of regulatory pressure and those types of potential fines, there is no room for operational inefficiencies in what we're doing to control, HVAC, lighting, air changes, and whatnot in our buildings. We must be controlling them in a smarter way. We have to be on top of that in kind of a real-time and ongoing manner. Number two, we need to be, thinking now about a future where we're swapping out our gas-fired, our oil-fired combustion appliances, so our boilers, our gas-fired chillers, our domestic hot water makers, et cetera. Those are going to need to get shifted out in favor of fully electric appliances, right? So heat pumps are going to be a heavily relied upon technology, or VRF systems, electric resistance, whatever it might be. But we're getting the on-site combustion out of the building, and everything's going to electric. And in the same, at or around the same time, the grid is going to be getting substantially cleaner because of the incorporation of large-scale renewable energy projects. Wind, solar, hydro, however you view nuclear, if that's part of that equation or not. But the idea is the buildings are going electric, the grid is getting clean, so everything kind of tip to toe in that cycle there will have been cleaned up through this process. Okay, so now let's talk a little bit about what the Internet of Things and software services have to do with this. So this is just a generic kind of shot at what the Internet of Things is, right? Good example, my neighbor across the street here has an IoT vacuum, and it's one of these little Roomba things, and it rolls around and gives him feedback on where the carpet is the dirtiest. He actually used this vacuum to bust his children illegally eating snacks on the couch because that's where all the little crumbs were. I just think it's a nice real world example where we have a machine that's generating data. The data is feeding back to management, in this case, my neighbor, and my management with this new kind of machine derived insight has the ability to make an operational decision. Do I bust my kids for eating on the couch, or do I not bust my kids for eating on the couch? That type of framework there, where we're generating data, we're analyzing it, we're using the insight to make operational decisions, can be applied to nearly any of the different kind of little bubble devices that we see out there, because that's what IoT is doing for us, folks. It's unlocking these new data streams that are allowing us to derive insights and drive new opportunities. A lot of the new opportunities for efficiency or for economics or whatever they might be in our buildings, they're going to be software based, right? By nature of engaging with the Internet of Things. So we're taking the data and we're layering new software services over it that are getting kind of increasingly intelligent and are increasingly allowing us to drive efficiencies out to our point of use in our buildings. All right. When we're looking at a commercial building complex, where are these IoT devices applied? They're applied in every single discipline that we might be seeing in a building. I generally spend a lot of time thinking about this in the context of HVAC control, your ventilation, your heating, your cooling. We could also be doing this with energy meters. We could also be doing this with lighting controls. But then we're also kind of branching off into a whole bunch of different disciplines. Vertical transportation, your elevators, et cetera, your fire alarm panel, your access control, your video camera, on-site surveillance, all of this stuff, because it's jumping onto a network, right? These are coming as IoT devices. They are IP devices that are, we're able to pull onto a network. We can then bring them into a single software platform and display the information from those devices on a single pane of glass. So we're starting to get now towards seeing the picture of how the built environment engages with these IoT technologies here. Okay, so let's talk a little bit now about the Niagara Framework. It's a building automation platform. It is globally the leading open building automation platform. My opinion, it's the best building automation platform in the industry. There's over 1 million installed instances of it globally. It's active in 77 plus countries. We have over 60 manufacturers that are working with it. We have a massive decentralized network of developers who are developing various different applications that can plug into or otherwise utilize the Niagara Framework. And the last bullet I have up there is that it also contains a multitude of protocol drivers. And that's kind of where the rubber is going to hit the road, folks, with how we do integrations in Niagara, right? If we have a protocol driver, we can do, kind of conversion from, so let's say it's a generic IoT device that's speaking its own protocol. If we have the driver for that, we can then integrate that IoT device into Niagara and display that information on our single pane of glass. So on our head end of the building automation system on that dashboard. That's really where the power and the magic lie in the Niagara Framework, is our ability to pull in many different disciplines into a single platform to allow either a portfolio level look down into multiple managed assets, or we could be just managing a specific building on that. But when you hear Tritium Niagara, I want you to be thinking that it is a platform for the integration of IoT devices. Okay, and what are some of the potential devices that we can integrate into Niagara that we're going to be seeing out, in the field, in the built environment? I'm showing them on the screen right now. Again, like I've mentioned a couple times, a lot of different disciplines pulling together into the same, single pane of glass platform that is Tritium Niagara. Okay. All right, so let's talk a little bit about building automation architectures and the impact that they're having on a digital transformation that is kind of being powered by the Internet of Things. All right. The way we've historically done building automation, you can kind of see in the left-hand column on the screen over here, right? So we have an enterprise supervisor up here. So this is at the server layer. That's on the network. That's going to ping down into a master controller. In Niagara world, we call that a JACE. Some of you on the line may be familiar with what a JACE controller is. And the JACE is going to be your kind of system network controller for all of your downstream field control devices. And that's where your inputs and outputs are going to happen to actually turn on a pump, turn on your chiller, turn off your chiller, etc. But if I can now focus your attention to the middle of the screen here, this is where we're seeing a kind of transformation in the digital technologies that are impacting the conversation we're having right now. Because what we're doing now is we're taking these field controllers that have historically been, kind of robust, tried and true, but have been operating on a slow network. This was historically a backnet network that's running at 78,000 bits per second, relatively slow. That's technology from the late 1980s. Well, now what we're doing is we're putting, multi-port IP switches on our field controllers here. And because we're doing that, we're kind of opening up the possibilities of how building automation can engage with these IoT technologies. First off, we're running at dramatically faster network speeds. We're over 1,000 times faster than that kind of 1980s style technology. So our whole network is deployed at a gigabit per second, right? So that is a massive leap in speed. Because our field controllers are now directly connected onto the network, they are going to have the ability to operate utilizing the Niagara software platform. I'm not diving in great depth into Niagara right now, but it is one of the leading cyber secure building automation platforms globally. The U.S. Department of Defense has kind of standardized on Niagara because of our cybersecurity features and posturing that we can set up. We can make this a very robust system that's kind of plays nicely with any sort of defense in-depth cybersecurity strategy you might be deploying. The software is FIPS certified. So when we can take that software and that super secure approach and bring that right down onto our field controllers, that is very good for our end user here. But it's not really has to do with energy right now. So let's get back to the network speed of this. When we can be pulling in data from IoT devices and integrating them on this high-speed network through these controllers that are running native Niagara, we then are going to have the ability to run real-time analytics on the various different pieces of mechanical equipment within a building. Okay, so we have the ability to run optimization and fault detection analytics on our air handling units, on our chillers, on our pumps, on boiler systems, whatever they might be, on our heat pumps. The speed of that network is going to allow us to continuously pulse these controllers. So ideally, within 15 minutes of a deviation or a fault being detected, then we are going to be able to quickly pick up that there's a problem there and take corrective action. If that could be a manual intervention, that can be a software-driven intervention, but we'd be able to quickly pick that up through an analytic and quickly take corrective action, thus keeping the building kind of performing as energy efficiently as it possibly can. Okay, the leap in speed I'm talking about here with this high-speed converged style network that I was just showing in the middle of the screen there. I think these are just a couple of good visuals there. On the right, the visual shows it for itself. We're going from what's essentially pretty much a dial-up speed up to a 1 gigabit per second speed. And in a more practical sense, that movie Titanic that was almost 4 hours long from back in the 90s, if you were trying to download that movie over a standard building automation network, it would take you over 10 days. If you were trying to download that movie over the high-speed converged network I was just demonstrating, you're talking about a little over a minute to download that movie. So that just gives you a good insight into the kind of leap in technology we're making in building automation. All right, so now let's talk about that concept of analytics a little bit, because that's something that's come up with our previous presenters, and obviously it's critical to driving down carbon and to pushing forward optimization strategies. So I want to think about this, the concept of analytics and BMS as kind of two separate things here, right? First up, we're going to have our edge analytics, right? So what I'm showing here is one of these IP-enabled high-speed field controllers, and baked right into that controller, right? This controller in this example is going to be controlling this cooling tower. This one's controlling a chiller, air handler, VAV box, etc. But baked right into this control sequence that's controlling this cooling tower, we are going to have fault diagnostic edge analytics, right? So these analytics are going to be continuously pulsing out to that piece of equipment that controller is controlling, and it's going to be saying, are you doing okay? Are you running okay? Are you running okay? Is anything wrong? Tell me if there's something wrong. And then if there's something wrong, we get an alert about it, right? And this is going to allow us to get towards a predictive mode of maintenance. So we can get out in front of potential maintenance failures. We can help guarantee system uptime. But most importantly, from the energy perspective, we can minimize slippage, that drift away from our commissioned state that a building is turned over in, right? When a building is commissioned, that's as efficiently as it's going to perform from an energy perspective. We want to keep that building there for as long as we can, and we can work towards achieving that by utilizing these types of ongoing commissioning and fault detection and diagnostic measures, okay? Studies show us that deploying those types of edge analytics, that fault detection and diagnostics, will save us around 20 cents per square foot, which typically equates to around 5% on your annual utility bill. And if you're looking at this graphically on the little chart that I'm showing right here, everything above the green line is potential energy saved by deploying a system that's utilizing fault detection and diagnostic style edge analytics. Okay, this phrase here is a synonym monitoring-based commissioning, or if you're familiar at all with the LEED program that rates buildings, they'll call that ongoing commissioning. It's all referring to that same process of continuously making sure your systems are performing up to high standards. Okay, so that's one type of analytics we do through BMS, and that drives energy efficiency gains for sure. The other type is going to be a cloud-based analytic. And building on some of the stuff that Stephanie was talking about, now when we're getting up into the cloud for our analytics suite, now we're talking about more of that data science approach, right? We're pulling in large data sets. It could be across, it could be one single building where we're looking at, every single piece of equipment and working with that trend data. It could be across a portfolio of buildings where we're accumulating larger and larger data sets and we're looking for anomalies in them. and potentially those anomalies will allow us to identify optimization measures that we can take. But the game changes when we can quickly get the data from the building up into the cloud and then allow that cloud software to kind of perform its magic. We know there's really good software that's being developed right now that can take a big set of data from mechanical systems in a building and create kind of recommendations on how to improve the performance of the building. So from my perspective, one of the most important things is going to be, how do we get the data from the building into the cloud as quickly as possible and in as streamlined of a manner as possible? Utilizing the Niagara Framework, we can use some of the protocols that we can interface with, as I mentioned earlier. Specifically, MQTT is kind of like a Cloud Connect protocol that we're seeing a lot of movement in our industry in that direction, where the cloud providers are wanting to interface with the controllers in the BMS, how we can most quickly get that data up into their cloud environment. And MQTT protocol is going to be a large part of that into the future. All right. Now, once that data has been kind of brought into the platform and analyzed, that's where our data visualizations and our dashboarding and whatnot kind of flows downstream from that process right there. It's the data accumulation. We layer the analytics and the AI on top of it. We create visualizations and dashboards to help managers most appropriately manage their assets. Okay. Future applications for this too. One of the points I really wanted to get home here, people, is that converged networks. So the idea of getting off of a slow bus with technologies from the 1980s, let's get up into the 21st century. We're going to get to high-speed networks. The networks are going to converge onto a single OT network. So that's an operational technology network. Then we can start sharing data. We can get the data onto the cloud, and we can get data back from the cloud more quickly. And we're really kind of creating the backbone and the infrastructure for future services that can be provided. Honeywell Forge is our big cloud, kind of big data analytics engine for energy optimization and predictive maintenance. And then Honeywell is also kind of intimately involved in both smart grid and smart city applications. That when you're talking about tying a building into a smart grid where it needs to be reactive to shifting loads or to demand response type of situations, and then even larger potentially into a smart city style application, we need that high-speed converged network with an appropriate middleware solution to help enable that. And that's what Honeywell is going to bring through our Niagara platform and through Honeywell Forge. Okay, so my summary here, high-speed converged networks are the future-proof backbone of the smart building, city, and grid. IoT is changing the game. New data streams are coming forward. As we can engage with them, we can drive efficiencies and create new value for our buildings. Faster networks with applied intelligence save money. They save us OpEx money. They save us CapEx money. Fast networks with applied intelligence save carbon. They're going to be smarter buildings. We can better manage our energy consumption and our emissions because of that. And fast networks with applied intelligence enhance the occupant experience, productivity, and drive new value. So that's gets me to my last slide there. So David, I guess I will hand it back to you, or perhaps Janine is the more appropriate person to hand that to.
Yes.
We're going to transition to Janine in just a minute. Let me just say that, that was a lot. The four presentations that we've just seen, I think is representative of the effort we have ahead with regard to carbon reduction. I think back on the presentations, it covered literally every aspect of life. So, and Janine, we've also run a little bit long, so I'm going to suggest that if you could pick out the best question that you had for each one of these speakers and pose them each one question and see how close that takes us to 3 o'clock.
Okay, so we got 2 minutes, I'd say. I'm going to go with Gary, if you're still here. This is a question I got here a lot, but could you just provide some details? I think to David's point, sort of what's the bottom line of what you think will happen with utilities transformation? Because I think it was a lot. So can you sum it up in 2 minutes?
2 minutes, I can try. I think in terms of the digital transformation of utilities, there's a couple of paths. One is the migration from analog to digital, digitalization, which is then sharing data across the enterprise. And the third is a business transformation. So that's one pathway. Second pathway is looking at expansion of the Internet of Things for utilities, looking at the software, whether it's operational software or whether it's analytic software, the connectivity piece, utility communications really addresses connectivity, and then the smart devices, whether it's smart meters, whether it's smart distribution automation switches, whether it's smart solar PV inverters, that's also part of the landscape. But I think the biggest transformation for utilities is how they manage the data. Today, most data in the utility infrastructure is siloed, tied to the application. And we don't share, or utilities don't share information across the enterprise. So I think with more cloud computing, you're going to see more commonality across the data. You'll see a data fabric or a data layer instead of siloed application-specific databases. And that is probably the biggest component of the utility digital transformation that's now starting. I don't know if that was 2 minutes or not.
Yeah, you did well. Actually, you did very well. So, Grant, there's two for you. I think of the two, the most important one is how you can you share out a program to bust the kids? But I'm going to skip that one and go with, if you don't mind, I think that was on everybody's mind, but what do you see as a future for building automation? Again, kind of the bottom line, what should we expect? There's a lot of information. So the 2 minutes summary, net.
Yeah, good. So I think what we're going to be seeing, and maybe let me give like a 5-year horizon, because past that, who knows? But what we're starting to see is the kind of equalizing of hardware platforms in a lot of ways. That once we get everybody onto the network, we're running at high speeds. It's going to be kind of a minimizing of hardware differentiation. And a lot of what's going to happen is going to be, how your services are going to be provided and where they're provided, right? So where they're provided, I think we're going to see a lot more cloud-based services. Right now, that has a very small amount of market penetration. We're going to see a lot more of that. Like I had discussed the idea of we need to get data up and from the building to the cloud as quickly as possible. That's a really big deal. And then how those services are provided, or maybe specifically by whom. I think you're going to see kind of bigger networks of potential service providers. We're seeing a constant erosion of proprietary building automation vendors out there. I know open platforms such as Niagara, we're taking share from them every year. So you're going to see more and more of that as building end users and owners want choice in who they can kind of procure their services for building automation from. So those are probably the two biggest I see.
Okay, that's helpful. Stephanie, see, we have 2 minutes, so I guess this is our last one. Stephanie, what about mandatory carbon audits and the dashboard you presented?
Yes, exactly. So in France, companies must carry on an audit every year, which is mandatory. And our tool is very complementary because it allows us to have an update of the carbon footprint on every day, for example, and you can make comparison at different levels, so between teams for different processes. And what is very important is that with this daily automating result, you can really act and follow the result of your actions. And following the result of the actions is what you need to engage your teams and what you need to really reduce your carbon emissions. So that's why our clients needed a specific tool to do that.
Thanks. David, you put one in here for Mark. And I think we see it here. How will utilities determine the carbon attribute of electricity delivered to consumers? So, Mark, you have 1 minute, but maybe we'll give you 2.
He can have more, Janine. And that may be something that all of the speakers want to weigh in on. How, everybody's talked about, well, we're going to electrify and that's going to reduce carbon. But, if that's the fact, how are the utilities going to be accountable for actually the carbon attribute of the electricity being delivered? That stuck in my mind during these presentations.
Yeah, I mean, I think it has to be through a real-time generation, real-time signal from carbon intensity signal from the generation side, right? So I think that's what we're starting to see, at least in some territories, coming from the ISO. I know PJM has done some work on that. Some small companies, I think Watt Time is working on delivering that to the rest of the market. But I think that's the way you get to actual true measurement, is through tying real-time carbon intensity signals from the generation side to real-time consumption measurement, and matching the two, and delivering solutions off of that. So it starts, garbage in, garbage out. So you got to get the right baseline to solve the problem.
Grant, you're going to turn all these buildings electric. How are we going to know what carbon?
Did David, any others come through to you, or?
We're good. Let's hear from Grant on this one.
Okay.
Yeah, sorry, the question one more time, David.
So how, if you're going to electrify all these buildings, and that's going to be the carbon emission solution for the buildings, how are we going to know what the carbon attribute of the electric power being delivered to the buildings is?
Yeah, so in the work that I'm doing, and kind of the market's local to me, that's provided by others is the answer. That's something that's kind of an equation that's baked into the policy, and I'd imagine that every year or so they'll make an update to that, and there will be a new carbon coefficient that we need to use to multiply out through our consumption. Certain how accurate that is, but I haven't seen a different way of doing it yet.
Yeah, I'm interested if Gary's seen anything in North America or if Stephanie's seen anything in Europe.
All right, I was on mute. So I think one of the challenges when you look at utilities and the discussion of carbon reduction, I think utilities will measure their output from their power plants to determine whether or not that's carbon free. But I think wind, solar, hydro, nuclear are the low-hanging fruit in terms of carbon-free generation. The other thing that utilities will be challenged, this is any business in general, including our business, which is what's the carbon footprint of our supply chain? How do we determine what is the carbon associated with our suppliers? And then also any end usage of energy by the utility, for example, vehicles to service customers or whatever the case may be, that's going to contribute to their carbon footprint. But big challenge right now, I think, is, a little less than, I guess the number one source of carbon is transportation. So we need to be able to track that. Number two is power generation. So we need to be able to track that carbon. That's going to get at a lot of the, take a lot of the carbon out of the industry. Utilities today, their generation 40% carbon free in the U.S., but that means 60% of the generation is either fossil fuel based and emitting carbon. So we need to clean that or retire it and figure out a way to replace it with carbon-free sources.
Stephanie, are we seeing anything in Europe where the utilities are able to quantify their carbon attribute or their electricity?
Yeah, I mean, in Europe, we have a lot of regulations and they are increasing. So, for instance, for example, right now, you have the European trading scheme. And so the energetical companies have to reduce their emissions, and they really track them. So we have like smart meters, and we have a lot of stuff to collect data and to analyze them. And also now, I agree with Gary, we have to integrate more fields. For example, transportation with its huge emitting part in France. because we have like an electricity production mix that is very carbon free, but transportation is the real problem. And we try to put like more taxes and also like penalties on that, like to really promote less carbon intensive solutions.
Janine, how about any closing thoughts?
Yeah, I think that was great. I think it was a lot, and I appreciate everybody being here. I think, David, do you send out the presentations? You send out the presentations afterwards, right? So everybody
Janine, what we'll do is we've recorded this video. We will send the video to the speakers and let them thumbs up or thumbs down on their individual presentations, and whatever we get approved, we'll share the video. We'll also, at that same time, Jess will ask the speakers if they want to share their presentations. If they do, we turn them into a PDF, and we'll share them. And that'll happen. Jess will be out in the next day or two with that email, and then hopefully next week we'll be able to share the presentations.
Yeah, and I know it was a lot of information. So, Gary or Grant or Stephanie or Mark, if we run into any significant questions and come back to us, we'll throw them out there for you, maybe, or connect either way if you're willing to do that. But I think you guys shared at the end really the bottom line, and that's the most important thing everybody needs to know. I don't think this topic is going to change. We could probably do a couple more on these, David, just kind of carving it out and continuing along this line as everything changes. So appreciate everybody being here. Any feedback would be great, and thank you. Have a great rest of your day. David, I'll turn it back to you.
Janine, we thank you for moderating. We thank SIA Partners for sponsoring, and Gary, Mark, Stephanie, and Grant, exceptionally well done. We'll be in touch within a day or so regarding the presentation follow-up. Thank you all, and thank you all for being with us today.
Yep, thanks.
Thank you.
Bye-bye.